3.3 rules for differentiation. So here we go. This is 40% of your exam right here. AP exam right here, not the chapter exam, 40% of the AP exam. So derivative of a constant function. F is the function, y equals whatever. So y equals pi, which if I recall is 3.14, it'd be like that. dy dx would be 0. Why? Because the derivative is slope. Horizontal line, slope equals 0. Watch out for it. Takes just a little getting used to, but still watch out for it. Now the power rule, which we already showed you. All right. Derivative of an x, this is a variable. Careful, because later on that'll be a constant. So watch out. Throw the n out front, subtract 1. How come? We proved it. All right. So y equals x to the third, y prime, 3x squared. Notice the different notation, y prime, d dx. I keep mixing it up. And how do we prove it? So what's the derivative of y equals x to the fifth? And I keep changing up notation on purpose just to keep you on your toes, 5x to the fourth. So that's the big one. That's probably the most important rule you'll learn all year. We're going to do something called infinite series in February, March. And we take things like tangent and sine and turn it into polynomials because they're so easy to take derivatives. We actually kind of show you the inside of numbers. It's pretty cool. All right, this one gets people, so just be aware. Early on, after a while, you don't really care. If there's some number out front, just ignore it. It just comes along for the ride. That's one of my favorite expressions. And every now and then a student will be like, wait, I don't understand what that means. Here it is. Here it is again. Didn't do anything to it. Just came along for the ride. So I really want to do what's y d dx of x to the fourth. The -2 just comes along. So dy dx -2 times 4x to the third, which of course we're not going to do that. We're going to combine it, -8x to the third. And we're going to do it in one step. So this just bothers people sometimes. We're just not really quick about it. And then the other one, if we have a trinomial or more than a monomial, what do we do? Well, it's easy. F prime of x, 3 out front, 3 times 3 is 9x squared. Derivative of -2x is -2. Derivative of 1 is 0. Going to be doing a lot of this. They call it summer difference rule. I'll never use that expression. I never use that, but it just means just take the separate derivatives. It's pretty straightforward. So here's an application. This is what they do. Hey, what are the horizontal tangents? I happen to know that horizontal tangents have slopes of 0. So, okay, dy dx equals 4x to the third minus 4x. Set it equal to 0 because of the horizontal tangents. 4x to the third minus 4x equals 0. And this is lesson 1 of 10,000 lessons of why you have to be really tight with your algebra. And quite frankly, this is why the math system is set up the way it is, Algebra 1 and Algebra 2, because when you get to calculus, it's got to be really, really quick. So where, if they asked what, I'd have to throw these solutions in. And I just broke an important rule for me personally. I like to put the -1 first, but I was just reading them out. If they said, what are the horizontal tangents? Then I'd have to plug this in and 0, 0. Okay, there's a horizontal tangent at y equals -2. Plug in 1 is -1. Nah, they're going to be the same. Plug in 1 minus 2 is -1 minus 2 is negative. There's a horizontal tangent at y equals 3. So there'd only be 2 horizontal tangents because the -1 is going to give me the same answer. So RTFQ, read the full question. Now, in a shocking move that will never happen again in calculus, we're going to get a bit more complicated. I know, you can't believe it. It's just amazing. What if we have two functions being multiplied? Well, hey, why don't we just, distribute them so that it's easier? This nonsense. So that would be x to the 5th plus, I'm going to do x to the 3rd. I like to keep them in order. X to the 3rd plus 3x squared plus 3. And then f prime of x would be 5x to the 4th plus 3x squared plus 6x. Yeah, that works. Nice. Well, there's something called the product rule. If you have a function, all right, and another function, you can do this one a little differently. So let's make sure we have everything on the page. So it says the first function, leave it alone. Notice this is a plus here, meaning I could do this forwards or backwards because I'm very lazy about it. I just say, which function you want to work with? It doesn't matter. You could go v du dx, put this here and that there. It doesn't matter. But I'll try and be proper about it. X squared plus 1 stays the same. So let's get this right. F prime of x. And derivative of the second one, 3x squared. Second one stays alone, x to the 3rd plus 3. Derivative of the first one, 2x. And that doesn't look anything like that, so I think you lied to me, Mr. T. I hate you for it, and I want to hunt you down and kill you. It wouldn't be the first time. So 2x to the 5th plus 6x. Anything in here I can, well, no, but I can figure out what I did wrong. 2x to the 4th, you dummy. All right, 2x to the 4th plus 3x to the 4th, I think is carry the 1. 5x to the 4th plus 3x squared plus 6x. Well, I'm sorry to disappoint, but so now the question, well, which way am I going to do it? Which way do I get credit for? How do I get the points? Man, shut up. Sorry. Yeah, do whatever you want. I don't care. So that was a product rule, and we will say product rule. We will reference it. How about a quotient rule? Here's what they say. They say low d high minus high d low over low squared. This is how people are taught to memorize it. It actually works, which is kind of surprising to me. This is the low. Oh, wait a minute. This is the low. This is the high. Technically HIGH, but hey, I'm being lazy. So it's low, put the V up top, derivative up top, minus and all I'm trying to do is help you memorize it. I don't really care how you do this. Minus high, u, d low over bottom squared. So here we got u equals x squared minus 1, and v, that's how I draw my v's, that little tail on it, equals x squared. So low x squared prime of x. I like to really show what I'm doing. Low d high 2x minus high x squared minus 1, d low 2x over, now there's no derivative here, low squared. Got some work to do. 2x to the 3rd minus 2x to the third minus minus plus 2x, x to the fourth, see ya, 2x over x to the fourth, 2 over x to the third. All right. And that seems awfully complicated. Isn't there a better way to do this? Can't I break this apart and just make fx equal x squared? Yeah, it's a common denominator, right? Wouldn't that be easier? That's a 1 minus x to the negative second. I do that so I can do the derivative. And f prime of x equals, derivative of that is 0. Negative, negative cancel. I get a 2x to the negative third, also known as 2 over x to the third. Holy cow, same answer. Do it this way for a little while until you get good at it. And then you can go separate. Well, 2 ways to do the same thing, Mr. P. You're really upsetting me. I'm so confused. I don't know where to go. It's not like you're going to show a third way to do it. Okay, how about if we find a third way to write this? This was the same function as before. I'm going to do something stupid. X squared minus 1, x to the negative second. Whoops, it's a positive second. We're going to make this negative, throw it up top. And hey, that's a product. Let's do product rule now. Can we do a negative exponent? Yeah. Same exact rules. Throw it out front, subtract 1 time. All right, well, like x, f of x, and I already showed you this. So f prime of x, throw it out front, subtract 1, and we typically do this after it. All right. Okay, cool. I'm barely following you. My brain's going to explode, but I think I got this. So f prime, leave it. Derivative, I just did it up there. Negative 2 over x to the third. Leave it. I'm going to put it on the bottom. Times derivative 2x. Well, that ain't what I saw on the previous page, so I don't know what's going on. I could cancel this and distribute that. Equals negative 2x squared plus 2 x to the third plus 2 over x. Cancel, negative 2 over x plus 2 over x, cancel, 2 over x to the third. Holy mackerel. This is the really fun part for me about calculus. It always works. If it doesn't, you screwed up. And quite often I do go, wait a minute, I'm not getting the right answer. What did I do wrong? And I slow down, I take a deep breath, and I go, okay, I got it. It's not a big deal. How would you check this graphically? Graph f of x and f prime of x. If you really want, and see if you get graph n deriv this, and then graph this, and see if they match up with each other. They will. It's pretty cool. All right, so 2 more quick things, and these are contrived math problems. They do this all the time. Hey, there's some weird function uv, and this is this, and this is this. Can you balance your checkbook? That's all they're doing. So y prime of 2 equals leave it v prime plus leave it u prime. Okay, u of 2 equals 3, v prime of 2 equals 2, v equals 1, u prime of 2 equals negative 4, 6 minus 4 equals 2. So they just put this in there so you can't use your calculator, and then they mess with you to see if you know what you're doing, blah, 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 blah. And last but not least, how do we do multiple derivatives? Pretty easy. Y prime, 3x squared minus 10x. So yeah, y second prime. Same thing. Here's where it gets a little loopy. The square goes up here. It makes sense if you think about it, but don't try and think about it because it'll just hurt your brain. 6x minus 10 Third derivative. Six. Fourth derivative. And you'll see this little parentheses with a 4. I thought for sure they're going to go with an IV or something like that, but no. And just, again, giving you a little bit of the nomenclature, just making sure you're aware of things. That's it. Oh boy, here comes a lot of problems. Good luck and happy mathing.